ML or Python. Instead, he is giving online classes. That is how smart he is. I have no idea about ML or Python. The only thing I know is law of karma. What you did in your previous life, what you are enjoying today, and what you are doing today is your future.
Video stop అయినట్టుంది. Okay.
You can see in Siddhartha, he was born very smart and intelligent because of his good karma in his previous life. What I'm trying to say to you kids is, be good, be kind, be respectful to others, your parents, your teachers, and everyone in general. Believe in God and pray God a few minutes a day in the morning and in the evening. Just make God is your best friend. You kids face a lot of problems, in the school and in your daily life. Just bring God whenever you can into your life. He's always available in your iCloud. Thank God for what he has given to you. You should thank him for giving 2 perfect eyes to see and 2 perfect ears to listen, and for giving food to eat every day. So many people in the world don't have enough food to eat every day. Just remember God in everything you do. If you can visit the temples with your parents, at least sometimes, a few times in a year. Enjoy your program. God bless you all. I want to thank Siddhartha again, and I wish him all the good future. You can start your program, Siddhartha. Thank you.
Thank you for the kind words, sir. Anyways, everyone, welcome to the Python programming course. So I'm basically Siddharth Pilli. I'm 14 years old, and I'm basically going to be the host and the instructor for the Python course for the next few weekends, as you can consider. Anyways, in this, so before we start, I just want to have a few things to be let in. One is the prerequisites for this Python course. Now, for starters, again, it's not necessary for you to have any prior experience in programming. If you have just have some good mathematical skills or just enough necessary mathematics, that's completely all right as well. So there's no need for any prior programming experience here, and it'll be and as today we're first starting off in today's session. This will mostly just be a small introductory session where I'll just give a small intro to what exactly is the whole concept of programming, what exactly is computer programming, and etc. So so we won't start off with the whole concept of programming just yet. So we'll first start off simple, understand the whole world around the mathematics, like the binary language, like zeros and ones of computer programming. What exactly is computer programming's main intention is, and then it's slowly going to turn into a learning curve where we'll be starting off with something like Python programming. But for today's session, we'll mainly start off with just simple, like just laying a small breakstone here to understand a small introduction to Python programming. Can we use Springkit.io for coding? Now, if most of you have installed your own Python, like if you already installed Python or something like PyCharm for writing your Python programs, I mean, that's completely fine as well. So if you want to use a certain ID or a certain environment, for today's session, we'll mainly start with oh, sorry about that. Anyways, if you want to use a certain ID or a certain environment to write your Python programs, for example, maybe PyCharm or Vim or Sublime Text Editor or anything.
Can we use
anything which is,
Replit?
yes, you can.
Okay, thank
Oh
you.
yes, you can use Rebel.id. That's also something which can use. But as most of the people here are beginners into programming, what I would recommend you to actually use is something known as a Jupyter Notebook. Now, Jupyter Notebook is actually a very simple, like user-friendly environment to create these Python programs in. So that's something which I would recommend. But again, we're just not here. We're just starting off with basics. So I won't get into ID and everything. These are just few simple prerequisites because again, I'm not just catching your own will here. You're free to do your own will. You can use your own type of ID, your own Python version. But throughout this course, we'll be using the Python 3.7 version and the Jupyter Notebook as our environment to create these Python programs in. So yeah, so that's basically a small intro. So it's just few prerequisites. So just give me a few seconds, Aaron. I'll just share my screen. So we'll start off with the session. I think it's loading right now. Just a few seconds, Aaron. I guess it's right now loading. Yeah, there we go. So just let me know, everyone, once the screen is visible. And again, if you have any questions, that's totally all right. When we start off a new concept, it's completely understandable that everyone has questions. But I would mostly recommend try not to spam the chat. End of the day, I'll definitely give a small segment for answering your questions as well. So end of the session, if you have any questions, I'll be more than pleased to answer all your questions as well. But we'll keep that as an end segment to answer all your questions as well. So hopefully my screen is visible, right?
Yes, we can see your screen. Yes.
Oh, all right, yeah. Is it okay to use Python 3.9? Yes, definitely. You can, again, you can use any Python version. If it's greater than Python 3, you're totally cool to actually use any version which is higher than Python 3. Yes, you can use Python 3 as well. So anyways, everyone, in today's session, again, normally the whole concept of programming comes under understanding how a computer works. So yeah, so today we'll be starting off with computer fundamentals, just understanding your basics of computers. It's not too basic where we're going to something like scratch or learning about what exactly inputs and outputs are. So we're not starting off with something which is scratch, but it's also not going to be where we're just going to create a whole bank application the next second. But sort of simple and just will lay down the basics and then we'll move on with programming. So yes, again, you can use any type of IDE which you want. So anyways, everyone will sort of with computer fundamentals. In today's so basically before we start, I'll just give myself get myself a small introduction. I'm Siddharth Pilli. I'm currently working as a data scientist at Infinity Learn Solutions in company right now. I've been invited as a motivational speaker and a motivational speaker and few few tech speaks as well for institutions, universities, and schools across India. I'm passionate about artificial intelligence and machine learning because it's truly going to be the next automation which is going to happen in very few years. I'm currently working as a computer vision and deep learning intern at IIT Hyderabad, and I have conducted many webinars on AI and ML for students across the world. So this is a small profile and introduction. So we can just get to know, you can just get to know of more of us, I guess. So with that, everyone, in today's session, we'll basically, these are the concepts which we'll be learning, where in today's concepts, we'll understand, in today's session, we'll understand concepts like assembler, compiler, interpreter, machine language, assembly language, and high-level language. And again, it's completely all right if you're not sure about what these topics are. It's totally a learning curve. So hopefully by today's end of the session, you'll be comfortable with these concepts. So with that, let's get started off with these concepts. So before we start off diving deep into anything, let's first understand the whole ideology of what exactly computer programming is. So, for example, let's say here we have just like a good hilly side, which is some road in the middle. And let's say here we have a small turtle a tortoise who's trying to, let's say, cross this road right now in this vertical way. And then here we see a car actually approaching this road right now. Well, it's clear that the turtle has to definitely move to the sidewalk if it actually wants to, cross the road, or it's the tortoise basically is going to get injured right now. So that's basically just a small sense of what exactly the tortoise is doing. And let's say once the car has, went off the street, the tortoise can start actually walking normally. So whatever we saw in this small slide there, let's try to just orient that in like a flowchart type of concept. So here we have a tortoise who approaches the road, and then the tortoise is checking if there's a car. Now, there are two things which can happen here. One being true, which means is there a car? If that statement is true, then the tortoise will basically wait until the car actually leaves. And let's say if this statement is false, which means let's say there's no car anymore, then the tortoise can basically cross the road normally. And this is the whole concept on what we're trying to achieve right now, where here we have an object tortoise and we're trying to make a decision. And based on this decision, we're trying to execute a following statement saying the tortoise is going to wait, or the tortoise basically is going to cross the road. And that basically what comes under the whole concept of computer programming, where computer programming is nothing but we're trying to draw these types of flows and charts to basically solve a problem. And right now the problem which we're trying to solve is a tortoise which is trying to cross the road. So just a small gist behind computer programming. Again, the whole concept of computer programming is, again, we're trying to solve a problem in a efficient and automated manner. And I'll get back to that in a few more sentences again. And now we'll look at something called computer languages. Now, it's completely necessary that whenever, if you want to, let's say, for example, if you want to write some programs, or if you want the computer to as we wanted it to, which means, for example, when we do things like programming, or when we try using Scratch or something, I think everyone knows about Scratch, right? Yeah, all right, great. So I think everyone basically knows about what exactly Scratch is. So Scratch, again, is like a small, simple computer language where we use these types of flowcharts to, do these few animations right now. And the whole concept of Scratch is that it only works if we try to communicate with it by using these types of like flowcharts and everything to create like a small program. And now when we come back to something called computer languages, now, when we normally talk, for example, we normally to communicate with a person to actually understand what the other person says, so we can basically act in the way which we want basically him to act. Now, how do we communicate with something like a computer? Now, for example, if you want to communicate, for example, with a friend, it's sure that we use languages like English or some type of Telugu or other languages to communicate with a friend, for example. But let's say if you want to communicate with a computer, well, it's completely sure that we can't use languages like English, Spanish, Hindi, Telugu, or any other language to communicate with the computer. So in those cases, we tend to use one of these three languages out there, where we tend to use machine language, assembly language, or high-level language to communicate with the computer. So these are basically what computer languages are basically used for. The computer languages are used for actually communicating with the computer to basically solve a problem. So again, here are a few notes from what we have basically discussed until now. Basically two sets: what computer programming is and what computer languages are. Computer programming is where we're thinking like and communicating with a computer, and is most commonly used to make long and repetitive tasks quick and easy. Now, for example, think of computer programming as an example of Zoom. Now, because of like whole pandemic and everything, we're trying to communicate over something like Zoom, and this makes it much more easier for us to communicate, share our ideas, learn something new. And imagine actually trying to come to an entire organization where you sit, you learn, and asking questions and everything. This would be even more harder, right? Because if you come to an entire organization, you have to wait for a seat, you have to wait for something else, etc., etc. This makes it a bit more painful and non long and a repetitive task, right, everyone? And yes, and with draw with something like Zoom right now, or with the help of Zoom right now, we're trying to make this long and repetitive tasks quick and easy with the whole concept of computer programming behind it. So again, that's basically what computer programming is. Another example you can think of computer programming is, for example, let's say you're trying to go out on, let's say, on a vacation, but let's say you have your plans inside your home. But for example, if you go on a vacation, it's completely sure that the plants may dry up, and you can't. The plants might dry up, and it might get spoiled. So what do you do in those in these situations? Well, you can't just come back to home after going to an entire vacation, just coming back to home and what your plans, right? But by using something like computer programming, we're trying to make this long and repetitive tasks quick and easy. So that's the whole concept behind what computer programming is, everyone. Is the concept a bit clear for everyone? You can just, I guess you can just use a thumbs up emoji if it's clear, I guess. Oh, all right then. So that's the concept. So that's the whole concept of what computer programming revolves under. And now computer languages. And again, for example, if we want to solve these types of long and repetitive tasks, it's it's necessary that we need a set of commands or instructions we need to use to actually solve these types of long and repetitive tasks. In those cases, that's one of the reasons why computer languages are there. Computer languages are nothing but these are just a set of commands or instructions which are used to communicate with the computer to solve a problem. And that's basically the whole concept of computer languages. These are nothing but just set of commands and instructions which are used to communicate with the computer to solve a certain problem. For example, think of the other problems I mentioned, for example, with something like Zoom or something like watering your plants. In these cases, if you want to solve this problem, it's necessary that you need to use a computer language, and that's where computer languages come under. So these are small notes. Again, you can take a screenshot, or you can just write this down in your notebook to just have this small reminder. So moving on, like we have said earlier, there are basically three types of computer languages which are available. One being machine language, assembly language, and high-level language. We will basically start off with machine language, understanding what exactly is machine language. So now I think we all have native languages or mother tongue, right? Do we? Yes, I think we do, right? So we all basically have our native languages or mother tongues to us. So, for example, even it's the best thing is even computers actually tend to have a native language or mother tongue to them as well. But for us, it's normally mainly something like Telugu, English, and etc. etc. But for something like computers, in this case, it is mainly known as machine language, where computers can only tend to understand what machine language is, and they don't understand anything else than what machine language is. So machine language is basically just, to be very clear, they're nothing but just they're nothing but just zeros and ones. So if you ever see machine language, this is probably how it looks. It's nothing but just zeros and ones. And it's not even it's not really zeros and ones. It's basically like circuit systems of like on and off, those types of concepts here. But machine language is basically nothing but zeros and ones. So For example, right now I have this entire like a huge like a blob of machine language right now, which contains 0110 0101101100001. So can anyone guess what exactly this 0110 is supposed to mean? Can anyone translate this? And again, don't try to translate it now, because one thing would be that this would be really even impossible to understand what exactly is happening here, because this right now is my name, Siddharth Srivastava Pilli. So that's basically this entire zeros and ones right now. And that's how complicated a binary system or machine language can be. Just to spell out my name, it took like at least a bazillion numbers of zeros and ones inside. You just print something like Siddharth Srivastava Pilli here. Then imagine trying to create applications or solve problems with something like machine language. It would definitely, many people would consider as something like impossible. But back in 90s or 1970s, people tend to use machine language to actually control computers or even create computers at the starting point. So here we have few computer engineers back in the 90s are trying to just fiddle with them like UNIVAC here. If I say UNIVAC, this might bring a lot of nostalgia, but UNIVAC is one of the first year computers. And these two female computer engineers are trying to use zeros and ones to, try fiddling up with something like machine language right now. But that's the whole concept of machine language. Again, machine language is nothing but just zeros and ones. And basically, in the early 1970s, they tend to use machine language to create computers or even or even write these programs with computers again back in the 90s. So and the funny thing is we still use machine language to this day as well. So right now in your computer, your mobile, or anything else, your processors or your CPU are still running on machine language to this day as well. So one thing which we have to remember is computers tend to use machine language, and machine language is the only language which computers tend to understand. So is the concept clear until now? I think the concept is clear until now. You can just give a thumbs up if it's clear, everyone. I guess in the chat or maybe inside your. All right, yeah, great. So with that, now we'll be moving on here. And few people are asking few questions. Isn't it binary code? Yes, it's also considered machine language has multiple names to it. It's considered as binary language, binary code as well. It's not Morse code. Morse code is a whole other way they tend to use these tabs and everything to make another type of language. So that's a bit different. And how long is the class? It will last mostly for like an hour or so. So anyways, that's basically the whole concept behind machine language. And don't worry, we won't be using machine language anytime soon right now. So moving on, now we basically, I think someone's annotating. Let me just erase that. Let me just disable annotations. There. So now we'll basically move on with the next concept known as assembly language. We're now going to move on with assembly language. Now, assembly language is mainly the whole computer era, but programming was a much more easier and much more, I guess, easier concept to get into than something like machine language. Because just few years back, we tend to use this. So yeah, we tend to use this right now to create different types of programs. But fast forward to next few years, we're using some actual text to create few actual programs and programs. So assembly language is where we'll be starting off with now. So assembly language, again, it mostly uses text and numbers to create these types of programs. And people tend to consider that assembly language is much more easier than machine language as well. The reason is machine language tend to use all complicated zeros and ones, where assembly language uses all text and everything. So now we approach a small question. Now, I previously just few sentences back I said that it's the computer's native language, or the only language which computer can understand is machine language. Then how is it possible to write assembly language when the computer's native language is machine language? Well, we use something called an assembler, which is used for translating assembly language to machine language. So to make it more clear, does anyone of you watch any types of YouTubers or something? Any content creators? I think everyone watches few YouTubers or content creators, right? Yeah. All right, great. So I guess most of you watch, and hopefully, did anyone of you heard about someone as the odds for now? All right, great. So this will be a good example then. So now we'll take a small example with the odds for now, James, and with some another example with someone like Jaden Animations. So now let's say here we have I'll just call him James for now because his real name is James and it's easy to call James in the whole word odds for now. But let's say here we have James here who only speaks something like English. So let's say James is only speaking English, and let's say here we have Jaden Animations or Jaden who only speaks Spanish again. Jaden does not speak Spanish for this example, which I will just say Jaden only speaks Spanish and does not understand English whatsoever. And let's say the odds for now and Jaden Animations want to communicate with each other. Let's say they want to talk, but they're basically limited because of their, because of these language complications. So how can Jaden how can James speak with each other? Well, they can definitely tend to use something like a translator, which will help them to, talk to each other. Where James here can speak English, so Jaden can understand through a translator, translate that to Spanish, and then Jaden can actually translate Spanish to English, so James can actually understand. And that's basically how they now both James and Jaden can talk with each other, even though there are language difficulties. And this goes with the same for something like assembly language and machine language in reality, where the computer can only understand machine language, but then there's something called an assembler. And this assembler is basically used for translating this assembly language to machine language so the computer can actually understand. So that's basically what this assembler is supposed to mean. Did everyone understand the whole concept of assembler and assembly language? You can just let me know in the chat saying yes if you understood the concept. All right, great, everyone. So moving on, now we'll basically get into what exactly are assembly languages which are used for. Now, assembly languages are mainly used for these four concepts again. Assembly languages are used back in the 90s again, or the 2000s as well. But most of the time, the assembly languages are used for developing games or simulations. So if most of you might have heard about games like Fortnite or Roblox, it's understandable that these games have something like physics engine. The way how the Roblox avatar moves straight forward, or how these Fortnite characters tend to move forward or backward or shoot with their guns, it's completely understandable that there's some type of physics which is going on to actually implement this. So assembly language in those days were actually used to create these types of physics simulations or even used for developing games. One interesting fact is that when Roblox was first created, it was not actually Roblox. I think it was something like just some blocks game or some generic title. And I believe it was actually developed using something like assembly language as a prototype. So Roblox in the starting stages, I believe it was developed by assembly language. And then assembly languages are also used for developing operating systems. Blocks party, that's what it's called. I'm not completely sure. Okay, I think I understand the question. If the assembler is a part of the computer, won't the assembler also only be able to read machine language, or is the assembler not part of the computer? No, no, no. The assembler is not a part of the computer. The assembler is actually a separate tool which is coming, which is coming with the assembly programming language, where this just basically used for converting this assembly language to something like the machine language. So it's not a tool which is inside the computer. It's a tool which is coming with the actual language. And yeah, so coming back to the concept, the assembly languages are also used for programming robots like simple machine tools. And one of the biggest fact here is assembly languages are also used for developing computer viruses. So back in the 90s, again, most of the time we are very vulnerable to something like computer viruses. Fun fact is that in the 2000s, the biggest computer virus mostly we all were attacked on was the Trojan virus. So that was the most common virus at those days. So yeah, so moving on, everyone. Now we have some small notes. You can just use this notes to understand, or you can just write down this notes in your notepad, or you can just take a screenshot. So until now, we understood that assembly language is a computer language which uses short lines of code and allows programmers to introduce names or blocks of memory that hold data. Or again, in simple terms, assembly language is mainly now assembly language is much more easier way of writing programs because it now includes text and machine language. Now, machine language is a computer language or a native language which consists of zeros and ones, and this is the only language which computer understands. And finally, assembler is a translator which converts this assembly language into a machine language or a binary language for the computer to understand. Don't worry, I'll try to share these notes through like any WhatsApp group or some type of group you all are available in. So I'll share this notes there as well. So there's nothing to worry. So that's basically what assembly language is. So hopefully this concept is clear for everyone, right? You can just yes and chat if it's clear for you. All right, great. So that's basically the whole concept behind what assembly language really is. And now we'll go into the much more mostly weighted part, which is the high level languages. So now high level languages basically where we tend to use all these languages in today's world. So for example, programming languages like Java, Haskell, PHP, Pascal, Objective-C, Python, Perl, and etc. etc. These all are nothing but high level languages. So normally these are considered, is Scratch a high level language? Well, yes, Scratch can be considered as a high level language, but the thing is, Scratch has a few limitations. We're mainly only awestruck to something like animations or games, but not something like, not something other than that. So yes, Scratch can be considered as a high level language in this case. And so yeah, so we'll start off with high level languages. I think we have a few more. Oh yeah, sorry about that. Yeah. So the whole concept of high-level languages come into case where these are languages which we actually tend to use in today's world. For example, applications like Zoom or applications like Gmail, Reddit, Instagram, or any of these applications were created using things like high-level languages. And even few of my favorite PlayStation 4 games like the Uncharted for The Last of Us or the newly I'm starting a bit, or the newly released the Insomnia game Spider-Man. All of my favorite PlayStation 4 games are also written in high-level languages as well. So that's the whole concept of high-level languages. Now, this is the type of programming language which we use in today's world to create new applications, games, computer viruses, animations, and etc. etc. So that's basically what high-level languages are. And right now, these are a few of the most famous high-level languages right now. So programming languages like Java, Ruby, C Sharp, PHP, C++, Objective-C, Python, Perl, Go, JavaScript, C, and Visual Basic are few of the famous high-level languages many people tend to use right now. And the thing about high-level language is that each programming or each high-level language has its own dependency based on it. For example, for something like JavaScript, the JavaScript is a great language for developing web pages. Or something like Java. Java is a good scalable application. It's it's like a useful good. Sorry, Java can be also used for creating these general applications as well. And for example, PHP is for web applications, Perl again, mostly normal scalable applications, Go scalable applications, and Python, a general purpose programming language. So each programming language has its own main dependency to work with right now. And so And what's the difference between Java and JavaScript? Again, I think many people tend to consider that Java and JavaScript are the same language. No, so they're definitely two different types of languages here. JavaScript, again, it's a whole other concept of they tend to use JavaScript to develop these like web applications, and Java is completely used under developing these general purpose programming languages. For example, maybe GUI applications and etc. etc. And JavaScript, they're mainly used in these web pages to develop those applications. So yeah, so moving on. Now we'll look at few advantages of high-level language in reality, where, for example, few of the advantages of high-level languages are they are completely English language. So, for example, different types of computer languages which we looked until now are mainly on concepts like machine language, which are only zeros and ones, makes it really complicated and hard to understand. But high-level languages are completely on based and oriented on English language. Another advantage with high level languages, it's portable, which means it, for example, you can be on something like Linux, you can be on something like Windows, Mac operating system, heck, you can even be on something like PlayStation and Xbox, and hopefully you can still write Python code inside it. And even I think it's even possible in the Nintendo, someone has definitely invented some package for that, but it's Python is, I mean, sorry, high level languages are completely portable. One of the other advantages with high-level language is the length is very small. To compare to something like machine language, assembly language, when you write anything in high-level language, it takes a very short space. And the next is problems are solved as well, which means you can be designing something like a calculus application to find out some type of functions or something, or you can also be using high level languages to create the next big applications used around by people. Anything can be basically created using high level languages. That's the whole concept behind high level languages. And for example, just how we had for something like assembly language, we had a translator called the assembler. For high level languages, we have a translator called interpreters to translate high level language to machine language. Again, interpreters are very simple to understand. Here we have some code, here we have the interpreter, and here we have to find out. But for example, let's say here we have some Python code. This Python code goes into the interpreter, the machine language understands it, and boom, you have your application right there. So that's the whole concept behind what exactly interpreter is. It's basically just transforms like just like a box. Basically, you just give it something, it gives you something else, something like that. So here's a small note for what exactly high-level languages. Again, high-level languages, basically programming languages designed to simplify computer programming to its fullest. So anyone at any age or with any experience can learn programming easier, efficient, in a much more fast manner way. That's the whole concept of what high-level languages. So again, you can write down this notes or you can take a screenshot or nothing to worry. I'll send these screenshot images to the WhatsApp group or the group where you all are available in. So now we'll basically look at the different generations of computer language and where we are right now. So until now we have machine language back in the 90s. Then we have assembly language introduced in something like the 1970s to 2000s. And right now we currently stumbled upon high-level language where we're currently in high-level language. We're very understandable with new and improved programming languages to make computer programming easier and better forever. So that's basically the whole concepts of computer programming and computer languages. So let's take a small summary on what we have learned in today's session. So in today's session, we basically understood what computer programming is. We looked into a concept called assembler. There is another translator for computer languages known as compiler, but compiler is only used for only one programming language, which is Java. Java basically is compiler to convert that to a .jvm file, then to a binary file, and etc. So I won't get too deep into that, but if you want to research the compiler, definitely, it's a very simple concept. It works exactly as interpreter, but it only works mostly for Java. We also learned about what exactly an interpreter is. We looked into concepts like machine language, assembly language, and high-level language. So these are the concepts which we have learned in today's session. So one more thing, I'll just okay. Anyways, that's basically what we mostly have for today's session, everyone. So I'll what's the difference between a compiler and interpreter? Well, interpreter mainly works in a way where it just converts the entire code to a machine language, but a compiler, it again, a compiler is only used for Java, where it for example, we have a Java program. I think it converts it to a .jvm file or something like that, and then that file is then converted into machine language, and then finally it can be translated to machine language. So it's a huge process for that, but that's mostly the difference. End of the day, these both are basically used as a translator. Do we need to download an app? If so, when will we need to download it by? So I'll be sharing materials, everyone, and these materials will be one to install Python. So we'll understand. I'll just give you a small document saying how you can install Python, and I'll also be providing another document to install something called Jupyter Notebook, so you can actually write your Python programs in. Are we going to learn about binary language and how to turn it into assembly language? Well, that's a huge process, so I won't be getting into that because that involves a lot of mathematics and etc. So we won't be learning about that because I don't think there's a necessary concept to it, but we'll mainly stick with something like Python for now. So if any questions, you can again just let me know in the chat. So I'll try to answer most of your questions regarding the course or the concept which we learned in today's session. Can I use Eclipse to write code? Yes, you can. I think Eclipse has some type of program available for Python. Can you spell out in the chart for type of book? Sure, everyone. So it's basically known as Jupyter Notebook. There we go. Can we get Python 3 or greater? Yes, if it's Python 3 or greater, you can definitely take that. Yes, the Python sessions are going to be every week as well. If you have any questions, again, just write in the chat. Can we write Python code in Chromebook? Well, yes, you can write Python code in Chromebook as well if you install it. I'll give you I'll just give you guys a few materials to install that. Can you please send this Google slide? I'll try sending the notes to everyone. Is Python 3.9.7 okay? Yes, that's completely fine as well. Ruby is basically a programming language. I never heard about idle shell, but if it works, you can definitely use it. Yes, you can use ideally as well. The classes will mainly be an hour. You can download Python there. Yes, you can use PyCharm. If there are any questions which are regarding IDEs and which Python version everyone, then the last basically, if it's Python 3 or greater, you can definitely install that. But throughout this course, we'll basically only use Python 3.7. But again, you can use Python 3 or Python 3. Anything which is greater than Python 3 is also great. I would recommend Python 3.7, but if it's greater than Python 3, it works. And you can use any environment you want, but throughout this course, we'll be using Jupyter Notebook. Are we going to have homeworks? Yes, we will be having homeworks. Actually, I'll be providing a few quizzes every week. I'll try providing a quiz this week as well, so it'll be easy for you now. I think that's mostly all the important question. Python is 1.2 is basically the started version of Python. Will these be posted? Hopefully, yes, I guess. What classes will be homework for everyone? Yes, we'll be starting off with coding in the next week. I don't have a PS5, I have a PS4. When was Python invented? Python was first conceived in the 1990s, and I think that's mostly what PC do have. I use a simple laptop mostly, and I think that's mostly good for you if you have PS5. It's really rare to get that. Anyways, everyone, I guess that's mostly what we have. No, I don't use an NVIDIA GPU, it's too hard. Anyways, everyone, that's mostly what we have for today's session. Again, if you have any more questions, you can definitely reach me out and LinkedIn or other things. And no, I don't have Nintendo. I do play Roblox, and I only have a PlayStation 4 as well. And yes, most often I play Fortnite as well. And no, I don't have Nintendo. Yeah, I do play Fortnite. Just then to then, I guess. What application do we download for Chromebook? Well, we'll be downloading Python and Jupyter Notebook. So it's the same for everyone, but you can just use your, if you want to use something of your own choice, you can definitely do that. All right, I guess that's mostly what we have there. So I'll try to mostly, we can take a conclusion there. Any doubts, you can definitely reach me out and I'll try to answer your questions there. But that's mostly what we have, everyone. Yes, I think I'll mostly stop the session there. Thank you, everyone.
Hey, can I ask you a small doubt?
Oh,
Thank you.
oh yes.
Actually,
Thank you.
Ash.
Thank you.
Okay,
Bye.
Thank you.
Thank you. Bye.
Thank you.
Bye.
Thank you. Bye.
Thank
Oh,
you.
bye.
Bye.
Oh, bye. Thank you.
Thank you, Siddharth. You
Oh,
will
yes,
be
thank you.
posting the homework for them?
Oh, yes, I'll try to give it to Vamsi, and I think Vamsi can actually post it
Okay,
there.
that will be really great. I think
Oh,
that
yes.
the session went excellent.
Oh, yes, thank you.
Is this working good for you? Like they can ask the questions in the chat and you can answer them, or should I open up in the end few minutes for them for you to?
Oh, no, actually, it's really good. I like communications as well, so I'm totally fine with that.
Okay, so last few minutes we can open up and they can ask you.
Yes, that works, I guess.
Okay, we just want to make sure.
Can you please
Nice.
repeat the meaning of assembly language?
Yes, I'm sure. Okay, the whole assembly language is mainly used right now. Again, it's basically just a programming language, but now we're actually using like text and words to actually a programming assembly language. Again, assembly language is just a programming language where actual code blocks, actual text variables to be have added inside it instead of more complicated machine language. We're revolving to something easier like machine language, like assembly language.
I missed the class today. Is there a way I can just for the future classes?
I
We
guess
have recorded the session. You can watch from our website or channel
yes, I
in
do
the
use
YouTube.
Discord.
Yeah.
How are you going
Yeah,
to
this class.
how are you going to send the notes and the homework?
I think there's a certain group you guys are in, so I'll try sending it there.
For the future
What's the actual timing of the class?
link, or are you going to send it?
No, I don't.
I'll be going.
I'm not in
I'll
the
be going to
group.
send it.
We
I
can
think
share
you
with
can
you in WhatsApp group.
There's
Okay.
a link on WhatsApp.
Yeah.
Actually,
Can
this
you
is my
send the
first
WhatsApp
class,
group
and
link in the chat? Can you
Yeah.
send the WhatsApp group link in the chat?
Yes, definitely.
actually, this is my first class, and I just joined the class. Then, what's the actual timing of the class?
It's 11 p.m. 11 a.m. in the morning Sunday, every Sunday for 12 weeks.
Okay, and is this the first class? I mean,
This is the first class, yes.
okay, what like up to where did you teach? I just want to know how up to where did
You
you teach?
can please you can check the recording in YouTube. If you go to Om Sri Sai Balaji Temple channel in YouTube, there's a recording of today's session.
Okay, thank you.
Are you post the recorded video on?
What's your YouTube channel so I can check the video?
Yes, it's Om Sri Sai Balaji Temple in YouTube.
Can you post the
You
WhatsApp link in the group
Yes,
chat?
we
In
will
the chat?
post, yes.
also wait. If you just pin, his there, it'll say live on YouTube, and so you can just it has an option where you can view the stream on YouTube.
Yes.
Are you gonna also post a recorded video on WhatsApp?
We can send the link of our channel and you can watch. Thank you. Thank you, Siddharth.
Yes,
If you have anything you want to say in the end, are you good for today?
I think that's mostly it for me, I guess. Maybe next session. Ramesh, yeah.
Thank you so much.
Oh yes, thank you.
Thank you everyone for joining. We'll be continuing for the following 12 weeks with Siddharth. We'll be recording every session, so you can watch in our channel in YouTube. Thank you. I will post the WhatsApp group link if anybody would like to join our WhatsApp groups, temple group, so you can get updates of our programs. Thank you. Thank you. Anybody else have any questions?